Welcome back, friends. Section 4, Table Structures, Session 7. This is the second session on table structures and last session on table structures. This session is about partitioning tables. This is Session 7. Agenda of the session is describe structures of tables, examine how execution engine access entire tables. That's what we have discussed. We have understood in the previous session these two parts, and this session is focused on identifying types of table partitioning, creating semantic partition tables, and how execution engine access partition tables. So the session objective is identify types of table partitioning, create semantic partitioned tables, and examine how execution engine access partitioned tables. Table partitioning. Table partitioning is capability to break tables into smaller, manageable slices of data. A data partition is an independent storage structure with a unique partition ID. It is a subset of table that shares the column definition and referential integrity of the table. Data in each partition can be processed independently. Partitions can be processed in parallel. That's the benefit of partitions. They give you performance benefit if they are processed in parallel. For a single task or different task can be performed on individual partitions. There are different types of partitions that you will learn and understand, and that is a very interesting topic from the query performance point of view, that you may choose to go for partitioned, and which partition will best fit into your need. Obviously that you need to watch out for this training for. We will discuss a comprehensive this topic will be discussed in a comprehensive manner. So this session is about understanding the partitioning concept. Monolithic versus partitioned tables. This is unpartitioned table. You are working, you have sent a query to the server where large number of deletes are happening. When the deletes are happening, the lock is acquired and all the rows are locked. Now other queries will be turned back. DSS queries turned back, update statistic turned back, OLTP app turned back, data load turned back. All queries are turned back when the entire table is locked or the pages are locked. However, if you have partitioned table like this partition, this partition, this partition, so you are working on a large delete. You have sent a query large delete query which is working on this partition, where other partitions are not affected by this deletion. Therefore all the queries which require other partition, like DSS query requiring partition, this partition and this partition, will be allowed and will be responded well. Similarly, update statistics require this partition. Suppose this partition is required, it will be responded well and it will be entertained by the server. Similarly, OLTP query, no query is turned back if you are using partitioned table. That is monolithic versus partitioned table concept. Benefits of table partitioning. You have seen that it increases operational scalability for very large database, that is VLDB environments. It minimizes contention between mixed workload applications. It eliminates partitions that will not be accessed. That is called partition elimination. It increases index efficiency through the local indexes. We will learn how to create local indexes, what local indexes are. Smaller indexes lead to more efficient access to data. It provides parallel processing for improved performance, which means concurrent multiple I/O on different partitions are allowed, and multiple threads on multiple CPUs working on multiple partitions. Enhanced database administration and management. It spread out maintenance tasks on large tables. That's a enhanced database administration and management. and it reduces impact on system availability during scheduled maintenance, because you are working on the partition, and the partitions which are not currently being maintained, they are available for the data processing. It inserts on partitioned heap table can be spread across multiple partitions, and BCP, that is bulk copy program, into partitioned heap table can be spread across multiple partitions. Scattering physical I/O across separate database devices. Partitioned table can use partition level locking instead of table level locking. That's a very interesting topic which I was talking about, and the figure also explains the same concept, partition level locking instead of table level locking. Different modes of partitioning. Semantic versus non-semantic partitioning. Semantic partitioning includes the semantic partitioning scheme has been available since Adaptive Server 15, but this scheme requires a license and must be configured. Row values are assigned to different partitions based on partition key and a logical rule which you specify. Non-semantic partitioning. The non-semantic partitioning scheme is equivalent to pre-SAP 15 partitions, and starting Adaptive Server 15, this partitioning scheme is default setting. So these are two, semantic versus non-semantic, and then we have index partitioning. With index partitioning, local indexes may be built on individual partitions. That is interesting, that we have individual partitions and we build local indexes on those partitions. That will dramatically improve the performance. Semantic and non-semantic partition strategy. Semantic partition strategy. We have three options here: range partitioning, list partitioning, and hash partitioning. What is range partitioning? The range partitioning, data distributed to specific partition based on the value range of a column. List partitioning, data set is broken into lists of values that are unique for each partition. And hash partition, data distributed according to hash function on columns or columns. Non-semantic partitioning is round robin. The round robin distribution of data among partitions. Data has no private partition key. Default form of partitioning, every table is round robin partition with one partition as a default. Does not require a premium license. So these are essentially four partitioning schemes. Three comes under semantic, and the fourth one is non-semantic, that is round robin. Let's understand one by one with example. Range partitioning. With range partitioning, the data is distributed to a specific partition based on the value range of a column or group of columns. In that syntax given here, you'll understand the values outside specified range cannot be inserted because we are specifying specific range. The keyword max used here, this max specifies the maximum value in a given data type. Now create table, customer, see customer key, integer not null, customer name, customer address, partition by range, and the key is customer key, which is specified here. And this is the criteria. Customer partition 1, this is the partition 1, the value are less than 20,000. Partition 2, value less than equal to 40,000, means between 20,000 and 40,000. I mean 20,001 up to 40,000. Customer partition 3, value less than equal to max value. So essentially we have here three partitions. Range partitioning benefits. Range partition is beneficial for extremely large tables. It is recommended for time-based data, for example monthly sales. The data that is ordered, for example price range. And the large table in high performance applications. It is useful for archiving the data like a rolling window operations. Rolling window means, for example, I am working on financial year 2021-22. So in 21-22, whatever data is, I suppose my retention period required by the government policies and liabilities is 5 years. So I create partition for every year. So partition, I'll create a separate partition for my sales data or for my accounts data for the year 2021-22, and this window will continue. After 6 years, I can continue safely delete the old partitions. So at any point in time, I will have a window of 5 years data available to me, and I can delete the old data. Or in other words, if I want to maintain the old data as well, I can find out the historical data by specifying the partition. And best part is only that partition will be referred which is participating in the criteria, which is a part of the criteria. So range partition allows for the addition of new ranges without the need to reorganize the rest of the table. Like this, 2006, 39 2006, 31 12 2006, 31 3 2007, 30. So this is a rolling window. If I'm continuously adding old data, I can safely terminate and I can safely delete and my window continue. And this is like the financial window I was talking about. The rolling window example I just explained that is partitioned by time. As time passes, partitions are added to the new data, and old partition may be deleted when the data is no longer needed. So you can use the syntax for the rolling window table: alter table sales, add partition, quarter, the partition name, the values with a given date. Alter table sales, drop partition, old partition is dropped, new partition is added, and this is we can have a rolling window of 4 quarters or every year. Recommendations: range partitions are most useful for columns in between clauses, like clauses for unbound range queries. The number of partition is in the tens to be low to the low 100s. Partition key join columns for frequently joins of large tables and are used in the columns where the partition elimination is not possible. Typical partition key include dates and alphabetic characters. For example, where order date between this date and this date. This will tell which partitions are to be scanned. Then we have a list partitioning scheme. With list partitioning, the data is distributed to specific partition based on the list of values. The values outside the specified list cannot be added to the column. And this makes sense if I talk about if I want to have the data about the states of a country, or countries of a continent, or countries of the world. Because I know that there are 7 continents, there are specific number of countries, there are specific number of states in a country. So that means no possibility of extra state or extra country or extra continent. So since that will not be the requirement, therefore I can safely use list partitioning in that situation. Let's look at this example. Syntax: create table nation, nation key, integer, not null. The same example I was talking about. It says nation key is used here, nation name, region key, and partition by list. Now here list is a region key is the list. Values Americans, region 2 is Asia, Australia, region 3 is Europe, and I can have additional regions if I want. And you know that there are specific number of regions in the world, so I cannot have unlimited regions, and there is no surprises for me as far as regions are concerned. That is why list partition is good in those situations. Recommendations: large tables benefit from data segregation based on literal values. Because these are literal, they cannot change. Limit the number of distinct values for the partition key. List partitions are useful only for equality queries. The number of partitions is in the tens to 20s. You can decrease the impact of database administration maintenance activities if you are using list partitions, and recommended the following list partition keys, which include type, status, and regions. Do not partition on primary keys. Minimize the number of values per partition less than equal to 10. Don't go beyond that. Hash partitioning. With hashed partitioning, data is distributed according to a hash function on a column or a group of columns. Syntax example of hash partitioning: create table, line item, order key, integer not null, and you keep on specifying the columns. This is a partition key, not null, and integer not null, partition by hash. And here what you are specifying is the values or the column which are used for the hash. Like here, order key and line number, and we are passing item hash 1, item hash 2, item hash 3. These are the three partitions which will be created based on these two columns, and algorithm will be used to divide the data based on these two keys. To use hash partitioning without naming the partition, specify the number of partitions you want. It is not mandatory to specify the partition names. You can simply specify the numbers, like for example partition by hash on these two columns, and I want 3 partitions. Hash partitions are useful on large tables that have no partition ordering of values on any key column. Hash partitions are useful only for equality queries. Attempt to distribute data evenly. The number of partitions is in the tens to 100s. You can decrease the impact of DBA maintenance activities if you use hash partitions effectively. Hash partition key use columns that are frequently grouped by or used in a distinct or union. Typical hash partition key include primary key columns, account numbers, product IDs, or taxpayer ID, or that kind of columns which include grouping of data. The default one was round robin. The fourth one, syntax example of round robin partitioning is quite simple. Create table, current publishers, publisher ID, not null, publisher name, varchar, city, varchar. Up to here is okay, but important is for us is partition by round robin, and you specify part 1, partition 2, partition 3. So we are creating 3 partitions, and the data will go to randomly, I mean in round robin format, 1 2 3 1 2 3 in 3 partitions. Is default partitioning strategy of adaptive server. By default, all the tables have single partition. Unless otherwise specified, all tables are considered a round robin partition with a single partition, one partition. Round robin partitioning. Backward compatibility for older version of adaptive server is available for round robin. With round robin partitioning, data is distributed among the partitions sequentially. There is no partition key or partition criteria. Each transaction adds data to the following partition. Round robin partitioning is susceptible to page chain length imbalance, which can reduce effectiveness. All of the rows inserted by a single transaction go into the same partition. That is a big problem, and that you will see in the lab assignment. I have a use case example demonstrated in this corresponding lab on the session. If you have subscribed to the session, you must go through the lab assignment on this particular topic. The transactions of different sizes can lead to partitions of different sizes. Partitioned table access. Partitioned tables require no change to SQL data manipulation language, that is DML commands. Queries accessing partitioned tables may perform partition elimination, accessing only the necessary partitions. You can use Showplan to see the partition elimination. Conditions. The following conditions apply to partition elimination in accessing a partitioned table. The table must be semantically partitioned, and the where clause must match the partition key. Only then the elimination, partition elimination can happen. Partition table show plan. This example show plan for the table scan of partition table. You see here table titles, eliminated partitions 2 and 3, and we are using table scan here. So that is how you can see the elimination, partition elimination based on the query. Partition management. To change the partition key, you can use alter table statement. Alter table, table name, for example titles, partition by range, total sales, small sales value less than 500, mid sales value less than 5000, large sales value less than 50,000. To add a partition to range or list partition table, you can use alter table command. Alter table titles, add partition, very large sales value less than 500,000. To add columns to a partitioned key, repartition the table using the alter table syntax. Only range and hash partition tables may use multiple columns in the partitioning key. Remember that as in the syntax if you recollect. Partition may be dropped on the list and range partition tables. Dropping a partition does the following. It removes all the data and drops the local index from that partition and rebuild all global indexes. To drop partition, we can simply use alter table, table name, drop partition, partition name, separated by comma if you want to drop multiple partitions. Quiz. I'm sure you have watched the lecture carefully. I leave it to you. Which of the following are types of locking schemes? Choose the correct answer. Under which two conditions table scans are performed? And this is match the type of partitioning with correct statement. Match the item in the first column to the corresponding item in the second column. And if you're listening to the lecture carefully, you will be able to match and you will be able to answer this question. That's all for this session. Thank you very much for watching. To know me, to know about me and my profile, visit my personal profile website www.rnsangwan.com. Thank you very much for watching. Bye bye. Take care.